In this video, we're going to look at discrete random variables. Let's start off by just considering those words and thinking what they mean. So, discrete. Discrete means that our variable is going to take one value or another, and there is a distinct gap between them. So, for example, it will be at point x is 1, or it will be at point x is 2. There is nothing in between these. There is no chance that x could take the value of 1.2 or 1.5. It is 1 or it is 2. That's what we mean by discrete, just like when we have discrete data. Okay, so random. Random means we don't know which one of the values it's going to take. It's not like a function, y equals 2x plus 3, where we know the value of y as soon as we know the value of x. It's completely random. There's no way of knowing until we've run the test or gathered the data what value of x it actually took. All we can say is that it has some probability. And then finally a variable. It is a variable. The value of x changes. Okay, so now let's have a look at the notation we're using here, because we've not seen a function which looks like this before. This is what we call a piecewise function. It has different functions depending on what value of x you're using. So let's look at this. It's telling us we should use this function whenever x is equal to -1, 0, 1, 2, or 4. Be very careful, we are missing 3 in this example. You'll need to look out for little things like that. It then tells us that it's 0 otherwise. So looking at this, that's telling us this is how we calculate the probability that x takes any value. A bit of nasty notation here. Lowercase x is the set of possible values that it can take. Uppercase x is the value that we actually get. So all we can look at is the probability that we actually get each one of those values. These can be pretty nasty to look at when they're laid out like this. So what I would suggest you do, whenever you get a discrete random variable question, unless it's the binomial distribution, which there are other videos on and that has its own techniques, and your calculator has a function which can deal with that all by itself, I would suggest that we draw a table. So we'll put the probability that x equals x on the bottom, and then we'll list out x values at the top. So the interesting x values are -1, 0, 1, 2, and 4. Notice again we do not include 3. We know the probability that it is 3. As 3 is not in that list, for all the other values, it has a probability of 0. Okay, so we've put this in a table. What is the probability that x is equal to -1? All I need to do is substitute -1 into this formula. That's going to give me a value of -1 plus 2, 1 times k. And then I do the same for 0. That will give me a value of 2k. 1, 3k, 4k, and then careful that you don't just automatically put in 5k here. 4 plus 2 gives me 6k. Always be on the lookout for little things like that. Okay, so we've got all of these probabilities, but they're in terms of the parameter k, and we don't know what that is yet. How can we figure out what the value of k is? There's one important thing we know about probability distributions, and that is that the probability of something happening must equal 1. As these are the only possible events, every other value of x is 0, we know that the sum of all of these must equal 1. So k plus 2k plus 3k plus 4k plus 6k must equal 1. So in total we've got 3, 6, 10, 16k is equal to 1. K is equal to a 16th. That's good. Now that we know our value of k is a 16th, we can just put that value in everywhere here. Somewhat unusually, I would recommend that you do not simplify these fractions, as if we're then asked a question like, find the probability that x is less than 2, we'll need to add up some of these values and it's much, much easier if they all have the same denominator. So probability that x is less than 2, we look at all of the values which satisfy that. Minus 1, 0, 1, not 2 because it's strictly less than 2. So we've got 6/16. You can simplify this answer if you wish. But you notice the addition was much, much easier. Also be on the lookout for questions such as probability that x equals 1.5. We do not go halfway between these two values. We were told earlier on that for any value not in that list, the probability that x equals it is 0. So that's what we'll say. There's one final bit of notation that we need for this, and that is the cumulative probability function. So f is how we denote it. F of x just means the probability that x is up to and including some given x value. So for example, if we were asked for f of 2.4, that's asking us what's the probability that x is less than or equal to 2.4. We look at all of the values which are less than 2.4 and we add up as we go. 1, 3, 6, 10, 10/16. Only one we didn't include was the 4. We don't worry that it says 2.4 and 2.4 is not in our list. Remember, it's an inequality. We accept anything up to 2.4. And that's a discrete random variable. Remember, the binomial distribution is just one particular type, but we are tackling that separately in separate videos.